Let's start with one of the last section of this Python course, that is errors and exceptions. As humans, as systems, you are prone to make errors, prone to make mistakes, prone to make some kind of encapsulation error or any kind of error in your Python programming language. So for that kind of language, Python supports us exception handling. So if there's an error, there are ways to tackle that error. We can make certain mistakes while writing a program, right? That leads to error while we try to run it. A Python program terminates as soon as it encounters an unhandled error. These error can be classified broadly into two types, that is syntax error and logical errors. Now, error handling increases the robustness of your code, which guards against potential failures that would cause your program to exit in a uncontrolled fashion. Now, as I told you that there are two kinds of error, syntax errors and logical errors. Syntax errors, these are errors when you don't follow a particular syntax. Let's say in print statement, you have not closed out the bracket, or in for loop, you have not given the colon. All of these comes into syntax error. Why? You haven't followed the proper syntax of the code. So these are known as syntax error. Let's take this example. So I have A, I have B, A equals to 8, B equals to 10, then C equals to AB. I haven't mentioned anything. So this is a kind of syntax error. If you want to plus it, then you have to plus. Then if you want to multiply, you have to write a multiplication sign. If you are not doing anything, then it will be a syntax error. So right now it is blank, so it will give me a syntax error because you are not following the proper syntax. Then we have logical errors, which are also known as exceptions. While in the runtime, an error occurs after passing the syntax test is called exception or logical error. Let's say you want to divide out two numbers. Okay, you want to divide out two numbers, but you have forgotten to write division sign and you have given multiplication sign. So 10 divided by 5, you wanted the answer 2, but you are getting 50 because there's some sort of logical error in your problem. In those kind of scenarios, these are known as logical errors and are known as exceptions. So errors that occur at runtime are known as exceptions or logical error. For instance, they occur when we try to open a file for reading. If you remember file handling, okay, for reading that does not exist, so it will give me an error. So if you want to open out a file which is not present, that is when the mode is in R, then it will just give me an error, that file not found error. Let's take one more example. If you try to divide a number by 0, which is not possible, right? So it will give me 0 division error. Or let's try to import a module that does not exist, that will give me an import error. Whenever these types of runtime errors occur, Python creates an exception object. If not handled properly, it prints a trackback to that error along with some details about why that error occurred. Now let's look into a quick example of it. So we have marks equals to 1000 and we are dividing it by marks divided by 0 and we are trying to print it. It will give me the error of 0 division error because you cannot divide a number by 0. So that gives me, or that throws me error. If we are not handling this error properly, then it will be quite problematic for us. Let's say you have 100 lines of code. In the 100 lines of code, you are taking a number from the user and that number gets divided from a particular number, right? So if the user gives 0, then your whole automated process will be stopped. It won't occur again and again because there occurs an error. So to handle these errors, we have exception handling. We have different blocks. We have try block, catch block, finally block. Okay, so we have try block except not exactly catch because that's in Java. We have try block and except block. So that's how we can do all of these. So let's jump into a Jupyter notebook. Before that, just remember we have try, except, and then finally. Then we have finally. These are the three things that we can do for exceptional exception handling. In try block, you write out the error, okay, whatever error you are gonna think that, okay, this part of the code will give me an error, so you can just write out the error code in that except block. So if the error occurs, so whatever you have written in the try block, if the error occurs over there, what will happen is whatever you have written in the except block, it will run over. And finally block, irrespective to if there is an error or not, it will occur anyhow. Let's look into an example. Let's say try. In the try block, you have written, you are taking an input from the user in A and you are dividing 100 by A. Okay, this is taken from the user, so this is an input from the user. Now if the user gives 0 as an input, so it will go over here and it will see that this is, there's an sorry, my writing is quite tedious over here. Okay, so except, I hope this looks like except. So except whatever you have written over here, whatever kind of code you have, let's say you have written a print statement. Print, you are trying to divide a number by 0. So if an error occurs in this block, in this particular block, whatever code you have written in the try block, then whatever you have written in the except block, it will be run off. So what I mean is, whatever error is there, it will be handled by the except block. But if there are no errors in the try block, then whatever you have written inside this try block, that will be occur just fine. Then one more thing we have finally. Finally doesn't depend upon any of these. So if there's an error in try block, except will occur. If there are no error, then try block will occur. But finally will occur anyhow. It won't depend upon your, if there is an error in the code or not. So that's about try, except, and finally. So let's jump out in our Jupyter notebook and let's get some hands-on view on all of these.